Okay, the question here is that the variable x and y, it is found to be differential equation x squared plus 1 dy dx is equivalent to k exponent of 2y, where k is the constant. Where k is the constant, it is given that y is equal to 0 when x is equal to 0, and y is equal to minus half when x is equal to 1. So we are supposed to solve the differential equation and find the exact value of y when x is equal to 3. So what we are going to do is that the first thing is to separate variables. So separate variables. Okay. Variables. Okay. So to separate variables, we are going to have x squared plus 1. X squared plus 1 divided by x, that is equivalent to k exponent of kx rather exponent of 2y. Okay, so to separate variables, we are going to have dy over d of 2y here is equivalent to kx this side, and we divide by x squared plus 1, x squared plus 1 dx. So we managed to separate the variables in x and in y. We can actually bring the exponent of 2y up. So we have d of minus 2y up is equivalent to ax all over x squared plus 1 dx. So that's what I get if I manage to separate the variables. Then I can integrate both sides. So to integrate both sides, I'll say integral of a of minus 2y dy is equivalent to the integral of ax over x squared plus 1 dx. Okay, so after integration, if I integrate this side, I'll use minus half of e of minus 2y is equivalent to k over 2 non x squared plus 1 plus 2. Then if I multiply everything by 2, I'll get minus e of 2y being equivalent to k non x squared plus 1 plus 2. So then I can then say let a is equivalent to this here. The one my constant that becomes the single letter like that. Okay. So the next thing is to use the first condition. Use the first condition. Now the first condition is saying that in y is equal to 0 when x is equal to 0. So I can substitute this my equation here. Then substitute in the equation to get minus e of 0 is equivalent to k non 0 squared plus 1 plus 8. Okay, then minus e of 0 is equal to negative 1. Then I will get that equals to a non 1. A non 1 is plus a, but non 1 is equivalent to 0. So I'll use my a being equivalent to negative 1. Okay, that's fine. So if a is equivalent to negative 1, then of course the equation becomes minus e of minus 2y is equivalent to k non x squared plus 1 minus 1, because I put the constant a inside there. So the next thing that I do is to use the second condition. Use second condition. So these are my stages. Let me just highlight them. The first thing that I'm doing is to separate variables. The next thing that I do is to integrate both sides. Of course, the next thing that I do is to use the first condition that I'm given. When y is equal to 0, x is equal to 0. And the next thing is to use the second condition. The second condition is actually saying that the second condition are actually saying, according to the equation, when y is equal to half, x is equal to 1. When y is equal to 1 half, when x is equal to 1. So actually now, maybe that's the case here. Okay, so substituting the second condition, I'm actually going to get minus e to the power of minus e minus half here. Actually, sorry, y is equal to minus half here. Minus half, okay? Then that equals to a a log is sorry, x is equivalent to actually x is equivalent to 1. So that's fine. A ln 1 squared plus 1 substituting 1 base minus 1. Okay, then if I simplify this, it will give me minus e of 1. It will be minus e of 1 minus e of 1 is equivalent to minus e of 1 is equivalent to a ln t, because that's 1 plus 1 ln t minus 1. Then if you simplify this one here, because I want to come out with this that time. So if you simplify that, I'll have a ln t is equal to 1 minus e a ln t is equivalent to 1 minus t. Because I want to come out with k, I'm making sure that you get the formula. Then divide by ln t. So ln t is equivalent to 1 minus t over ln t over ln t. Cancel k will be equivalent to 1 minus e over ln t. Alright, that's the value to get ahead. So the next thing is to substitute k back. So I'm taking k back. I'm substituting k back. Alright, that's fine. I found now the value of k, so I can substitute it back. So to substitute k back, I'll get minus e of minus 2y is equivalent to 1 minus e over ln t, is multiplying ln x squared plus 1 minus 1. Then to solve out that, I will actually, if I, alright, I will actually get something like this. Minus e of minus 2y is equivalent to 1 minus e, then ln is in bracket ln x squared plus 1 over ln t minus 1. So now I want to find, so I'm using this expression here to find y. Find y when x is equivalent to 3. Okay. Find y when x is equivalent to 3. So I'm not substituting for x is equal to 3. That's why I'm leaving out y method, because it's the one that I'll make subject the formula. So I'll get ln 3 squared plus 1 is equivalent to ln 3 plus 1, okay, which is actually equivalent to ln 4, because the ln 4, or rather, it's 2 ln 3. Okay, that's fine. So then to equate this side and what I get here, I'll get something like e of negative e of minus 2y is equivalent to 1 minus e 2 ln t. After simplify the this one here, ln root 2 root 3 squared 2 ln 2 over ln t minus 1. Then to simplify it, I'll cancel out ln 2, of course, cancel out ln 2. So I'll get, finally, I'm going to get minus e of minus 2y is equivalent to 1 minus e minus 1. That's fine. Alright, that's fine. So the next thing is that because this one here will multiply this two and negative one here. Okay. Then the simplify of this. Um, if we simplify here, we get e of negative e of 2y is equal to 1 minus 2e. Okay. So if we put the negative the other side, we get e of 2y is equivalent to 2e minus 1. Then to introduce the log both sides. So it will be log e of 2y is equivalent to log 2e minus 1. Okay, so then so this is minus this is negative here. So log of exponent will eliminate exponent there. So minus 2y will be equivalent to log of 2e minus 1 then over 2 over 2 over negative 2 over negative 2. Okay, that's fine. So this will give me, I can cancel out, this will give me y is equivalent to minus half ln 2e minus 1. So that's the one which is in the mapping scheme here. That's how it is.